All right, for this next part, we are going to look at a payout annuity. And really what's happening with a payout annuity is that a person, instead of depositing an amount every month and then watching it grow, it's kind of the opposite. You actually pull out money on a regular basis, and the money that's left over is earning the interest. And basically it's going to slowly empty out your account. This type of annuity is often used for like retirement, when you say like, I need $5,000 a month to live. So you have saved a bunch of money your whole life, you have this chunk now, and then slowly you're going to basically pay yourself back. So we're not going to prove that here, but this is the main formula that we will be talking about. It's kind of similar to how we did the formula for the annuity. But it's just going to be slightly different again because you're going to be losing money every month with those regular withdrawals. So we have the same letters going on here, the same variables. So we have P naught being the balance at the beginning. D is going to be the monthly payments that you make. We have our interest rate, the number of times that it compounds. We have the number of years that we plan to take those withdrawals. Notice the negative exponent on there, and then we're dividing by that R over K. So similarities and also a couple differences. So let's take a look at a situation here. We have Katerina is planning for her retirement. So she's setting up a payout annuity with her bank. She wishes to receive a $1,200 per month payment for 20 years. So the question is, well, how much money does she have to have in there when she retires? So we really don't know that amount. So stepping back, we do not know the balance in the account at the beginning. That's what we want to find out. But we do know that she would like $1,200 every month. And we're going to have, be careful, there's like parenthesis within parenthesis. So it's 1 minus, we have 1 plus, our interest rate is 0.08. We're going to divide by 12 because she's going to receive that $1,200 every month. This is going to be to the minus, careful with that, NK. So she wants to do this for 20 years. So it's every month for 20 years. So we're going to say 20 times 12. And then we're going to close off that parenthesis. This is all over 0.08 over 12. And so if we punch that into a calculator, what this is going to be looking like, we could simplify a little bit. If you want to, you could reduce that. 20 times 12 is going to be negative 240. Again, make sure that you use that negative exponent. And when you enter it in, it ends up being $143,465.15. And so if we want to find the total amount of money that she withdrew by the time that money ran out, well, she was receiving $1,200 a month, and she wants to do that for 20 years. So if we multiply that out, it ends up being $288,000. So that's how much money that she actually was able to receive. But notice that it started out at only that amount. That's because as she took out $1,200, yes, the balance would go down, but it was still earning that interest. So to find the total interest, all we have to do is take out that amount she started with from what she was actually paid. And when we subtract that, we end up getting $144,534.85 in interest. That's awesome. And so lastly here, to describe the difference between compound interest, a saving annuity, and payout annuity. So those are the three things that we've been talking about. One of the big things that I think about from my own perspective, if these are all kind of like savings, is that the compound interest is normally one payment. Like you only make one deposit. I said payment because we've been talking about that. But the annuity, the savings annuity, is going to be multiple deposits. So many deposits. And each one will be earning a little bit different interest because each one has been in there for different amounts of time. And then lastly, the payout annuity, that one is going to be many withdrawals. So we want to try and keep those all straight. And again, that one you start with a big amount that slowly decreases over time, but you're still earning interest on the remaining, so there will still be an interest amount made. And that's it.